As I'm recording this past week we broke the record for the hottest average global temperature 3 times. That's 3 separate records broken in the space of a week. The water you can see behind me is the North Sea, and it's renowned across the UK for being really cold. But recently it's exceeded temperatures of 4 degrees average for this time of year. And for over a decade now, climate scientists have been telling us that we must not exceed 1.5 degrees in global average temperature. And it seems like we're going to go well past that 1.5 degree mark by 2030. A lot of the impacts of climate change we can see around us. Less rainy days, hotter days, animals coming out of hibernation months earlier in some cases. But what's happening where we can't see? How is global warming affecting underneath the sea? What changes are happening there, and how is it affecting our marine life? Hi, how's it going? I'm Adam, a marine biologist, and today I'm going to be discussing how global warming is affecting our oceans beneath the waves and what that's going to do to our marine life. Welcome to Naturescope. First of all, we're going to look at how has global warming already affected our oceans, temperature increases and the knock-on effects from that. And then later in the video we're going to look a bit deeply at 2 of the effects I think are really going to change and cause issues for our oceans. Since the early 1900s, the average global ocean temperature has risen about a degree. Between 1900 and 1970, this was about half a degree's rise, and since then to present day, another half a degree has been added on top of that. I'm sure some of you are saying, well, just 1 degree Celsius doesn't actually sound like a lot, and just hearing it, it really doesn't. But the knock-on effects from that 1 degree increase are absolutely astronomical. Things like fish and coral reefs rely on stability. They're like stable temperatures, and to understand what time of year it is based on the temperature. Now the 2 animals I just mentioned, fish and corals, will have different ways of dealing with this warming. Fish, on the one hand, will just move. They're able to swim, they're able to get away quickly. So let's say it's too hot in one area. The fish can move either north or south to get to an area that's more comfortable. Corals, unfortunately, do not have that ability to move, and therefore have to stay put. We're already seeing a massive decline in our coral reefs, and if the temperature rises above 2 degrees in the ocean, it's estimated that they could be wiped out completely through coral bleaching. Now we'll talk a little bit more about coral bleaching later on, but let's first of all talk about the effects of no corals and no fish in an area. Having no corals where there once were millions, and having no fish or specific species of fish where they once were abundant, is disastrous for ecosystems. What it means is that the fish that weren't comfortable in their original environment will have to move, which completely changes and morphs that environment that they've switched over to, leaving the environment that they were in effectively dead. Let's talk about a specific example. Here in the UK, if you ask any fisherman over the age of 70, they'll be able to tell you that when they put their rod in the water when they were a child, usually a cod would come out. They were really common. But now, a cod is a prized fish, and if you catch one, it's really rare. But why have the fish become so elusive to catch? Well, it's a combination of things, one of them being the fishing itself. The fish has been overfished to a point where populations are declining. But the main factor is that the fish has started moving north towards the Arctic. Cod are not the only fish to do this. In Aberdeen, Scotland, squid have become increasingly common, with fishermen there pulling out hundreds and tons of squid a year to export around the world. If you look back 30 years ago, squid were incredibly rare to catch there. This is because the populations have started moving north to cooler waters. It's estimated that there's over 1,000 other species doing the exact same thing. Now, in principle, this sounds fine. The animals just move north, so the fishermen and the predators just follow them. But eventually they're going to run out of land. When they get to the Arctic and that starts heating up too much, where else can they go? We're likely looking at the extinction of sea bass, of squid, and of many more animals due to rising temperatures and them running out of suitable, comfortable water to go to. Rising temperatures will also see a decrease in food availability in the ocean. Most animals, most marine organisms will only breed when they're completely comfortable. If they're not comfortable, if the environment's not right or it's too hot or too cold, then they just won't breed. This will see a decrease in the number of juvenile fish and younger animals, which is no food for the medium-sized fish, which then means the predators like sharks, have no medium-sized fish to eat, and so on, and it effectively has a knock-on effect for the entire food chain. I said earlier we'd come back to coral bleaching, so let's talk about that. Coral bleaching is the process of corals effectively losing their colour and dying out and becoming this horrible white colour that you will have seen on many David Attenborough documentaries. If all the corals in the reef are bleached, they have no way to reproduce, which then means the reef is dead. Many animals rely on reefs. Juvenile fish hide in the little cracks, little crevices that corals provide to keep them safe and allow them to grow into adults, and fish like parrotfish will feed on the coral and the surrounding plants to sustain themselves. Inside corals there are cells called zoothanelli, and these help corals to photosynthesize. They effectively provide food for the coral to live off. In return for providing corals with food, the coral provides a hard shell for the zoothanelli to live in, and this protects them for most of their life. However, if it gets too hot, the zoothanelli leave the coral, which means the coral then has no way of getting food, and that's when you see it lose colour and become white, and that's due to a rise in sea temperature. Now, corals and reefs aren't just an exotic thing. They aren't just in the Great Barrier Reef in Australia or in Egypt. In the UK we have many coral species. They're not all as colourful as the ones you see abroad, but they're still equally as important here as they are out there. So with all of the fish dying off, all of the predators dying or moving north to cooler, more comfortable waters, and all of the corals and plants dying off too, it will effectively leave our oceans empty and soulless. Now I know someone out there is thinking, well, why does it matter? We can't see underneath the ocean, we don't see it every day, so what's happening under there won't affect us. And thinking that, you'd be completely wrong. There are many knock-on effects that we'd feel from having our oceans and fish and plants all die out. First of all, we'd see a huge decrease in food availability. Even if you don't eat fish, billions of people living in coastal communities across the world rely on the ability to catch and eat fish, so people would be going more hungry than they are now. We'd then also see even more rising temperatures on land. The ocean is a fantastic sink of temperature. It holds in heat extremely well. If there's no animals and no plants and no activity, more of that heat will be released. The ocean is also a fantastic storage place for carbon. If all of this carbon is released by the environment being destroyed, then it will mean even further temperature increases on land. Today I've only touched on just a few of the things, a few of the effects that are caused by our oceans heating. There's absolutely thousands more that I wasn't able to touch on today, but I just wanted to talk about a few of the really important ones that I think will dramatically change our ocean in the next 2 to 3 decades. So hopefully you've been able to learn something in today's video. If there's anything I've missed out or anything you disagree with, leave a comment down below. Share the video with a friend and leave a like, it really helps us out. And subscribe to Naturescope to not miss any more future videos. Thanks again for watching, and I'll see you next time. Cheers.